For that, again, I'm back in our dummy project setup, which we used over and over again. In there, we can run npm start to bring up that development server. And then in a new terminal window, with the server running in a different terminal window, I'm running tsc-w to start my TypeScript compilation process and keep that up and running. With that, of course, we got an empty page because there's nothing on it, but now we can play around in the app.ts file and get started with generics. And I think it's easiest to understand generics if we have a look at a default type, which is built into TypeScript, with which we actually worked a lot, which turns out to be a generic. And that would be an array. Now, let's say we have an array of names, Max and Manuel, let's say. So we get two names in there. Then, of course, the type of the names constant is an array of strings. Now, actually, we could think of this as two types being combined. Just as you can have an object with different properties, where in every property you might be storing a different type, an array also is just a thing with different data in it, in this case with strings in it. So we actually have the array type, just an array. And if I would remove the names here and cut them, you would see that TypeScript would infer this to be an array of type any, so with any data in there. Indeed, TypeScript knows the array type. So we could say this here should be an array. But as you see, if I specify it like this, we get an error, even though I can tell you that this array type written like this exists in TypeScript. But we see that it's a generic type and that it requires one type argument. And now that's something we haven't seen before. We never heard about generic types before. Now, this strange notation here, whenever you see something like this in TypeScript, you're dealing with a generic type. A generic type is a type which is kind of connected with some other type and is really flexible regarding which exact type that other type is. Sounds difficult? Well, let's go back to that array example. We know that we want to store an array here. So an array itself could be a type. It's a list of data. That on its own already makes up a type, you could say, just like an object is a type on its own, even if we don't know yet which data will go in there. So an array is a type on its own. But an array, of course, stores data of a certain type in there. Now, the array type itself does not care which type of data is stored in there. The array type does not care whether you're storing a list of strings, of numbers, of objects, or of mixed data. The array type really doesn't care, but it does care about getting at least some information. Even if you're telling it, I don't know, by setting this to type any array, it's better than not specifying anything. Now, this is one way of defining an array type, the type of data which is stored in there and then square brackets. The other way, which would create exactly the same type, would be to use that array thing and then these angle brackets. And now between these angle brackets, you specify the type of data which should go into the array. For example, a string. And this here is 100% the same as defining this type here. And of course, here you could also use a union type to say, this array stores strings or numbers, or you use any if you don't want to say anything about the type, or as we just had it, string. So this is a generic type built into TypeScript. A type which is connected to another type where we want to know which other type that is so that TypeScript can give us better support. Because here, for example, if we know that what we store in there will be a string, well, then we know whenever I access an element in that array, I can do string stuff with it. I can call all these string methods, for example, and TypeScript will not complain because it knows, well, this array holds strings. That's the idea of generic types. A certain type, in this case the array type, might simply work better or work at all if you provide an additional information about a type of data that's provided in this array type. And of course, the array type is just one example. Another generic type, which is built into TypeScript, is the promise type. Now, promises are a JavaScript feature, right? It's not a TypeScript feature. You can create promises in JavaScript. And in case you're not sure what promises are, attached you find a link. A promise can be created by using new promise. Again, this is a constructor function, a class built into JavaScript. And the promise constructor function takes one argument, which itself is a function, which then in turn will get two arguments eventually, a resolve and a reject function. Now these will be passed in automatically to us by JavaScript and the browser. And then in a promise, we can, for example, set a timer. And then in that callback function of that timer, we could resolve the outer promise. So in here, in this callback function, we could call resolve and say, this is done. Now, when we do so, this promise here creates a new object, a promise object, which is stored in the promise constant. Now, this promise constant actually has a specific type. It's of type promise, and then again, you see these angle brackets, because this promise eventually will resolve to something. Now here, it says unknown, because TypeScript is not fully able to understand that we actually will resolve to a string here. But therefore we could say this is a promise which eventually will yield a string. And we do so by, again, using our generic type. The main type is promise. But a promise, just like an array, kind of works together with other types. An array used other types because it stored data in it, data of certain types. And a promise works together with other types because eventually it kind of returns some data of some type. And in this case, that's a promise which eventually returns a string. Now again, why is that useful? Why is this extra type information useful? Well, if we just had a promise type here, and that would not be allowed, but if we said promise of type anything, which would basically the same as if TypeScript wouldn't know generic types, if it wouldn't have any information about what we get back, well then on this promise, of course we can use then as we can do in all promises, and eventually we'll get some data, but we know nothing about that data. I can't call a string method on it, for example. Well, I can because it's any in this case, but I don't get any particular TypeScript support. I could also try stuff on it, which definitely won't work. For example, if we turn this around and we return a number here, I could still call a string method here because TypeScript has no information about the data this promise will eventually yield. Now with generic types, we give that information to TypeScript. We can tell TypeScript that this promise will eventually yield a string or, in this case, a number, and then TypeScript can warn us here. If I try to save this, it will give us an error because it knows, hey, this promise eventually will yield a number, and you can't call split on that. So we get better type safety with generic types. So you're really flexible regarding what you do with that generic type information. An array knows which data it stores, a promise knows which data it returns. If you build your own generic classes or functions, you might do something totally different in there. But in the end, generic types help you to get additional type information if you got a more complex class or more complex function that does something with the data that's coming in a way where it doesn't really care about the data being of one particular type, but where you want to store the type information of the incoming data to get better TypeScript support whenever you work with your generic type. So whenever you work with that promise or that array. That's basically the idea of generics. So this year, all were built in generics. Let's comment that out. Let's now build our own generic type, or let's use our own generic types.